Okay, guys, good evening. My name is Paul, and today we'll have Kelvin handling the section 4 of our Cairo Bootcamp. Last week, we had CC tackle writing Starknet contracts, and he also built a simple ERC20 contracts on Starknet. But today we'll have Kelvin put us through testing in Web3, types of testing, and also go through Starknet Foundry. So, Kelvin, you can just take it up from here.
All right, thanks, Paul. Good evening, everyone. Ademola Kelvin, like known as Code Whisperer. So, yeah, think like it's nice having us back again to like join the session, and today we'll be going through testing using Starknet Foundry. So, there isn't much slide, just okay. Let me share my screen. Uh, it's more of like an hands-on experience. Yes. So you can see my screen, right?
Yeah.
Yeah. So while the session is going on, if you have any question, feel free to like ask, and also like keep tabs on the comment section or the chat section rather. So what we'll be taking a look at is like testing in Web3 and type of testing, Starknet Foundry, and also like a little bit of like an introduction to Starknet Foundry. So basically, there's nothing really like um, new as regarding to like Web3 testing, although um the what do we call it? The stakes are sort of like different, right? Say I don't like our background or our experiences, but if you have like a little bit of experience in Web2, you know that when you either you like write your front end or you like write your back end API implementation, you have to test and ensure that your code is working as expected before being pushed to production. So what makes Web3 like very very different is the fact that you have contracts, right? The contracts are immutable, and this contract holds like chunks of dollars, right? And there's there are always like vulnerabilities if your contract are not like tested or audited properly, right? So it's always can you guys hear me?
Yeah.
All right. So basically, things are moving fast, right? And it's always very, very essential to ensure that you like test your smart contract before you push them to production or before they hold any real value, right? And sorry, someone saying something. All right. Okay. So when you write your smart contract, like what are the types of like testing that we have, right? You have unit testing, you have integration testing, and then you have end-to-end testing. So unit testing basically is you like testing your um, functions like individual functions, right? And then integration testing is like setting, having like a different module to like um, tests for different case scenarios of your contract or your code basically. And end-to-end testing basically is like you testing from a UI, and you know that when you say you write a contract and then you deploy on Etherscan, or sorry, Stack Scan or Voyager, it's somehow like stressful going to the scan to like test your contract and things like that. So you have to like create like a testing environment where you can test your contract, right? So this is where so this is just to like give you a graph of what end-to-end testing is, integration testing and unit testing, and the the tools you can use in like in different scenarios, in different test scenarios. So unit testing, right? You're testing individual functions, right? You can use Cairo test, which is peculiar to SCAP, and then you can use Starknet Foundry. And then we're doing integration tests. You're basically like testing like the public interfaces of your contract in this case, and end-to-end testing where you have like tools like Cypress or Appios. End-to-end testing is not our primary focus. So little bit of introduction to like other testing. You have like manual testing, which you test like testnet to UI, force testing, fork test, and some other things like static analysis, formal verification, invariant testing, and a lot of other things like that. Right. So, brief introduction into Starknet Foundry. I don't know if some of us are familiar with Foundry, which it's a tooling for writing Solidity smart contracts. Um, yeah, so Starknet Foundry is like similar, right? Earlier, I think as far back as Cairo Zero, the popular toolings back then was like Protostar, and Protostar team sort of like migrated to like creating the Starknet Foundry. So Starknet Foundry basically enables you to like write Starknet contract, test Starknet contract, and give you like out of the box functionality similar to Foundry, which is used for Solidity. But currently, it's not like as robust as Foundry, but then it's still a work in progress.
Sir, Chief.
Yeah, so testing contracts, right? So um sorry, I don't have a slide for setting up, but I'll just like walk us through the process, right? I have Starknet Foundry already installed in my local directory, but then the installation process is quite like straightforward. All you need to do is like copy this command here, and it's going to download like set up your environment for you, and also you can install specific versions. So one thing to note is that Starknet Foundry is dependent on SCAB, so you have to like ensure you have like the latest version of SCAB, and also you have the latest version of Starknet Foundry, because there are always like breaking changes, which is one of the reasons why it is essential to be in like Telegram channels or Discord channels of these tooling, so you can get latest information and know what is new. So if I should like if you want to follow along, just go to Starknet Foundry. Let me share the link in the chat. So you just follow the where is chat. Okay. So just follow the installation guide. The installation guide is pretty straightforward. And once you're done, you can just do SN Forge. Then you get version. Then it's going to show you like the version of Starknet Foundry that you have. So to start with, to initialize a new project, you basically like initialize the project using SNForge init. Then you specify the project name in this case. And what I'll do is session 4 testing demo. So it has created the project, and then we cd into it. Please let me know if you have any question. Yeah. Yes. So you can the project we like initialize now has an src folder which contains a lib.cairo, and it contains tests, right? And also it has like a scab .uml file, basically like where you can add dependencies and like customize dependencies, scripting, and all those environment variables required by your project. So let's take a look at a simple contract that was generated for us here. So we'll start with this, right? We'll see unit testing with sorry, let's testing with this, and then we have integration testing. So there is already a test written here, right? So but we just like go ahead with the unit testing directly. So unit testing, basically like you're writing the test in your project in your contract module, right? And this is a simple contract that specifies a Starknet interface. You have increase balance, you have get balance, and then you have then you're specifying that this is a contract with these attributes, right? And you have a storage variable here. Basically, I believe that we understand what is going on here, right? You have a function that increases the balance and a function that decreases the balance. So say you want to test for individual functions in this module, you have to like start by specifying CFG test. Then you create a module called test, right? So we need to like bring in a few things here. First, we have to like bring in our contract, and I believe like we understand how to like do that already. Super hello Starknet, and you know that when you create interfaces, right? Um, the compiler automatically like generates a dispatcher for you. A dispatcher gives you a way to interact with your contract to make external calls and or, like yeah, basically. So we are going to bring in the dispatcher, and also bring in some configurations from Starknet Foundry itself. Remember that when we're declaring contract, when you're deploying contract, you have to declare before you deploy. So the same processes follow for testing too. And then we have class trait. So we'll start by creating helper functions. This is just my approach of writing tests, right? Yeah, the helper function is basically like a deployer to help us deploy our setup. So function deploy contract, and okay, she's going to return a contract address. Please let me know if anything is not clear or if I'm being too fast. And know that Starknet gives you these types out of the box. You can just import them in, right? So now what do you want to do? Firstly, you want to like declare our contract here and then return the address. So this setup is basically like a helper function to help us like declare our contract and give us the contract address. So what we'll do is say let's contract equals to declare. And what is the name of the contract we want to like declare? Hello contracts here, right? So let me just like show us the interface declare so we can know, yeah, declare. Yeah. So declare a contract returns a contract class, right? Function deploy and precalculate address can be called on the struct, right? So this is like this is how it is implemented in their code base, right? But then when you're making use of it, right, it gives you you declare, then you specify the name of the contract you want to declare. So the name of the contract we want to declare now is hello what? Hello contract. Yeah. So to get the contract address, contracts dot deploy. So this deploy is expecting a parameter, right? And the parameter is expecting is say when you're deploying your contract and then you have constructor parameters, you have to like pass in the constructor parameters, right? But then when you don't have any constructor parameters, all you just need to do is specify um array traits. Then you unwrap. Basically, I have to like bring in array in here. Yeah. So now I can return the contract address now. And so most of like when you're testing, most of the things you'll be doing is you'll be asserting, right? Okay, that your your function invocation returns so value and stuff like that. So I always like refer to like create an error module and say which is going to like contain some constant, say constant invalid balance, which is a failed 252. You know, your error um your error message should not be too long because Starknet doesn't support what do we call it, like long strings for now. But I think that is still like a work in progress. So as time goes by, we should have like support for that. So and like so it's contract, you can't have like long error message. So you just have to like keep your error message as brief as possible. Now we have the setup that returns the contract address to us, right? Now we can now begin to like test our contract. And when you want to like test your contract, you have to like specify the attribute test on it, and then you specify the function, and your test should always like begin with the test keyword test, say increase balance. So just like are we following, please? Any questions so far?
Fully.
All right, okay. Yeah, thanks for paying attention. I appreciate it. Yeah. So scarf commands format the code. Yeah, so we want to test for increased balance. Now we are going to like use our setup here, our deploy contract here. Say contract address equals to deploy contract, right? And how do you like we need to like make calls, right? That's where our the dispatcher comes in, where you I the dispatcher, and then you know that your dispatcher expects a contract address. No. But then this is like a repetition. Since it's same parameter, you can just like specify contract address alone. So now that we've like called that now that I pass, like I declared the contract here, I deployed it, right? And it returns to me the contract address, right? Basically from what we got here, name of a contract as short string, and gives you um yeah, it gives you the class hash. So if I don't unwrap here, it's going to like give me the return type would be a result, but then unwrapping it's basically like let me get out the data I need from it. So passing in the contract address, I'm able to like access the functions, right, that I can invoke in my contract. So if I should do dispatcher dot, so you can see that you have your increased balance, you you have the get balance, right? So what we want to like do now is say increase balance. Say we specify like a constant amount, amount to increase should be
I
felt.
have a question.
Yeah, go ahead.
This helper deploy contract, is
Yes.
it part of test or it's just part of the code you're trying just to deploy the contract?
So it's just part of the code I need. Okay. Okay. Yeah, it's part of the test, but then it's not a test. You remember that I said whenever you want to like test, right, you always specify the um attribute test, right? So when you run SN forge test, this deploy contract is not seen as a test because it doesn't have like these attributes specified on it. Basically, what we are doing here is we are using this as a setup to like declare our contract and also deploy our contracts, because the approach would have been that for each test I want to like write, I deploy, like I do all these steps again, right? Like I bring this inside this place. It's a lot of stress, right? So
I
just to
get you.
abstract that out, that's why we have this helper function. Do you get?
Yes.
Yeah, so we can just easily get the contract address out directly without having to like repeat the steps again. So this is why when I execute this deploy contract here, you can see that it returns this contract address, and you can return more than one parameters from it. It's not restricted to just addresses alone. I believe like we know that. So to increase balance now, say I increase balance by amount to increase, right? Now I am going to like
Sorry,
assert.
excuse.
Yes.
On that same note, like on line 48, can you explain that line
Okay.
of code?
Okay, line
The
48.
get contract address, yes. Contract.deploy, I say an array trait new. So is that variable contract address an array of addresses or what's, can you explain that
Yes.
line?
So when we start testing, like I'm just like using this as a demo, right? When we get into like the details of testing, right, you would see. So you're in Starknet Foundry, when you want to like pass in constructor parameters, say your contract has a constructor parameters, let's say we call it call data, right? It has to be specified as an array, right? So say you're deploying an ERC20, you have your name, token name, symbol, and etc. Do you get? So it's an array, and we're still going to like see that soon. So I'm just like using this as an introductory stuff for us. Is that clear?
Yes. So if that array contains that array contains really what? Is it parameters of one contract or is
So
it an array of contract addresses or what
no.
does that
It's
array
it's it's
contain?
an it's an empty it's an empty array. You know that when you want to like declare a new array, say you want to declare a
Yes.
new array, right? You see, let's say you want to declare a new array that says array A. How do you do that? You do array. No. This should work. So basically, like you're creating like an instance of like an array here, and in this place, right, you have to like pass in the array. But in this case, you don't have constructor parameters, as you can see. In this function here, there is no constructor, right? So we have to like pass in an empty array. That is why we are passing like creating a new array here, and then like passing the variable as passing it as
I
as
get
as,
you.
as a snapshot basically, and then you unwrap it. Yeah.
Nice. Understood.
Is it clear?
Yes.
Please, are you sure that it's clear?
It's clear because you've said this contract address, this variable it should be an array, and that array should contain, you said the constructor parameters, but since it doesn't have, we have just declared like an empty array.
Exactly. That's like the idea. So we've increased the balance here. So we want to like assert that. So let's get balance. Let's say balance equals to dispatcher. So we have to assert that balance is equals to amount increase. Then the head valid balance. So to run your test, you run snforge test. This should work now. Okay, sorry, it's running the test in these other files too. So let me just yeah, so our test passes like that. So we are certain that the amount we pass in here is actually 100. And also, if we should go back to the code, we can see that in this function increase balance, it's saying assert that amount is not equals to 0. So there are some properties you can like test for. Should I call them properties or like attributes you can test for? Um, it's called should panic. So when you're writing your test, you can sometimes like ignore a test, and you can like watch out for specific attributes. Let me just search for it. Should panic. I think it's on okay. Okay, I'll just like show the example directly. So let's say I want to like highlight this test now, and the attribute I was talking about is should panic. You might be wondering that what is this available gas? What is it for? Available gas is basically when you're writing test in Scalp, you have to like specify the available gas, but those things are covered for you out of the box in Starknet Foundry, so you don't need to like specify that. So say you want to like function test 0. Please don't mind my function names. Right. So what we want to test for is now should panic when you are expecting a function to fail, right? You can use should panic. So say you know that from here, if I should pass 0 as a parameter, it's going to like revert that amount cannot be 0. So I want to like test that okay, this assert actually like works as expected. So I'm going to like specify here that remember get my contract address deploy contracts okay dispatcher equals to so I'll do the same step here dot increase balance. So I want to increase by 0. So you can use scarf format to like format your code. So you know that we can see from here that it says amount cannot be 0, right? So what I'm going to like specify here is I expect that this second execution should revert with should panic with amount cannot be 0. So let's try that. Yeah, so you can see that it passes. And another attribute that we can take a look at is ignore. I think, no, let me just should be showing up your that test. Okay. Okay. So the only if I got this correctly, you should only like execute this second test. So it's going to ignore this test. So when you have like a number of, say you are testing your, so you can see that it returns just this test 0 param. So say you're like running a large code base, right? And you want to like ignore some tests and put priorities on one. One approach is to like run that particular test using like a flag that says maybe match, then you specify the function name you want to, the function you want to test. So another approach is to like use the flag ignore. So the compiler is going to ignore this test. Yeah, so this is that's like the simple idea regarding testing. Now we're going to like go into today's um, work really. So we're going to like start with what do we call it? We're still going to like write some unit testing. So the difference now is that your tests, unit testing, you're testing individual functions, right? Yeah. And when you're doing integration tests, you're like doing it separately, where you're testing like the public interfaces or their external functions made available to you there. So you have like a separate file for it. And if I should uncomment this test, it still follows the same approach, right? So we have a helper function that deploys our contract. And what is it doing? It receives the name, and this declares basically specifies like the name of the contract. And when you want to run the test, you have to like do put the name of the contract and um, specify the contract address in the dispatcher, call your function, assert, and basically we get the idea. So I have a contract I wrote somewhere here. So we're going to like do sort of for that instead. So I'll clear this one. I delete this. Yeah. Yeah, basically. Yes. So we have the nearest 20 contracts, basically. So we are all familiar with ERC-20 contract. So we're just like going to go straight into like testing and like seeing the functionalities. So there are like testing is still like the same, but then there are like different approaches to which you can use. I if time permits, I'm going to like show us like a second approach. So we know that we have to like specify if you're doing unit testing, you want to like test in the individual functions in this contract here. We have to specify the test flag. And then remove this. Let's see, 20. Yeah, so we need to like basically we need to like create upper functions for deployment, which is going to be please any questions so far? Right. Is someone speaking? Okay. Um, okay, all right. So in this setup now, you know that the setup we have will be different from the one we did earlier. Because why? The function here, the contract here basically has a constructor parameter, and what we know about constructor parameters are they are functions that like initializes the state of our contracts, right? So they are like very useful in different case scenarios. So you have a contract that you want the deployer to be the only person that can execute like functions there. Upon deployment of that contract, you have to like specify the constructor parameter and specify like the deployer or the required address you want as the owner of the contract to do that. But basically, the idea of constructors are to help initialize the state of your contract. So we have to like take cognizance of that in our testing too. So what we are going to do is we
So
require
you've
some.
said you've said you've put constructor such that the owner. Just clarify on that.
No, no, no. I was just like giving a scenario. Say you write a contract, right?
Yes.
And then in one of your okay, let's say let me give an example. Right. Okay. Say we have Starknet Africa quote two contracts, right? And they want to like assert that we want to make sure that the deployer of that contract is the one that can like execute certain functions, right? You would have implemented this logic in the functions you want the deployer to call it, right? So now, how do you like specify the deployer when you want to deploy your contract? Like, how do you specify what do you call it? Say the admin in this case when you want to deploy your contract. So constructor is good for things like this. They help initialize the state of your contract, right? I don't know if you're following the analogy I'm giving.
Yes.
Yeah. So say I want to deploy the contract now. It's going to require that I specify the address, right? So that's the idea of constructors. And the former contract we saw, the simple contract we saw, doesn't have any constructor parameters. So it's just direct, right? But in your ERC20 contract, it has a constructor parameters, and the constructor parameter basically is to initialize the token name, the token symbol, and the token decimal, right? So the use cases varies, right? So whatever you want to like do will determine maybe your contract is going to specify a constructor or not. But then this is one use case, right? You know that for every ERC20 token or either for every token, either fungible or non-fungible, you have to like specify the properties name, symbol, and token and decimal, right? Not I don't think decimals are necessary for Miracle 721s. But basically, you need to like specify this upon deployment, right? So that's like the idea. So we have contract. Yeah, I wanted to like import some things inside. So we need std sn forge. You need your declare. Remember, you have to declare your contract and then your contract class traits. Yeah. Right. So we are going to declare the name of our contract is ERC20. ERC20 and get contracts address to be contract dot deploy. So sorry, a minute. Uh, so let's see this deploy. Deploy a contract returns its address, right? And it receives some parameters, right? It gets it receives self, an instance of contrast class structs that can be obtained by invoking declare. And then you have the constructor parameter snapshot of the core data for the constructor. Now, so you're saying that you've declared your contract here, and then you want to um, yeah, you've declared it here, and then you want to deploy it. That means you have to like pass the constructor parameters, right? So this is just like showing us deploy is, what declare is. Because if I should go back to this function, say I do, you can see that it gives me class hash, it gives me deploy hat, and also pre-calculate address. So in this section of Forge library function references, you can like check out what each of these functions, or like each of these method do, and how you can use them in your code depending on your use case. So I want to deploy, and you know that I have to like specify my constructor parameters. Now, how do I like create my constructor parameters? Say I want to like just specify here as a 20 constructor. Let me just call it core data. And the core data I'm expecting, right? It's name, symbol, and decimal. So I want to like create them as constants, token name, and you can choose to like write them directly in your function. Token name, say token demo comes token symbol td td, and then comes token decimal, so first 5, choose 18. Right, so these constructor parameters. Now remember when someone asked how is it always like specified as an array, and you have to like take cognizance of the order in which you have written your constructor parameters, right? Your symbol should not come before name, your decimal should not come before name. So we're going to like specify those parameters in this order: token name, and then we have token symbol, then we have token decimal. Now I'm going to pass this as a snapshot. Yeah. So this is still like claiming an error. So what this returns basically is so I have to like unwrap it to get the contract address and return contract address. Yeah. So the setup is pretty much done. Now we have to like start testing. So I will sorry, let's take a pause. Any questions so far? I hope like we're not like confused. Just some feedbacks before we proceed.
Okay, sorry, I
Right.
have a question.
All right, go ahead.
Yes, in the first unit testing we looked at during contract deployments, we
Yes,
made use of the array traits, new, and stuff like that. So
yes.
I'm wondering why we are not making use of the array traits here.
Yeah, so if you want to like you can still make use of the array traits, right? Array traits name, right? But here is going to require me to append the data. I have to do append, and I don't want to like go through the stress of trying to like append token name. Here I'll see code data dot append token symbol. Yeah, so I have to specify. So now, I'm using array trait now, so I have to like specify it as a mute that is mutable. So that means I can mutate the value of this right here. I'll see call data dot append um, token decimal. See, it works. So it's just personal preference. The first approach is like is clean and sort of like straightforward. Is that clear?
Yes, it is. Thank you.
Yeah, thanks for asking. I should have like made differences and clarification about that. And you can, if you go into see, they follow the same approach, right? You have like constructor parameters here. I don't know if my screen is so tiny, but yeah. So you are specifying your constructor parameters. You're creating a new instance of array here, and then you define this as a mutable variable. You can call data.append. Then basically that's the idea. Yeah. So I want to create a path module where I am going to like specify function user1, which is going to return a contract address, and it's going to return to me user um traits trying to use Starknet. Yeah, so I will need some addresses to like mint token too, right? So instead of um just doing random address saying let say const user1 equals to ox um, OX01 or OX02 or something like that. Because this OX01, I think there are instances where it might clash because I think some of these like OX01, OX02 variables are being used in the core core implementation of Starknet Foundry. I'm not sure in particular, but then if you need to like create an address type, right, you can easily like create a function that is going to like typecast a felt into a contract address. That's why we are importing this try into, because if this try into is not there, okay, it works. So basically, just typecasting this user into an address, you can see it returns a contract address. So I want to like specify a mode error to const.
So you said to generate a user, you just used the trait Starknet contract address,
Yes. So
and it creates a test contract address.
yeah, to create like a test address, right? Like a random, like no, random is not the word to use, but to create like an address, right? Instead of you using random value to say let's use equals to 0x01. This one works too, but it's advisable, right? It makes your code much cleaner and like more let me use the word like say
Mm.
professional one way or the other. So you have this function user1 that returns a contract address, and then what you are doing here is this field here, you are typecasting it to a contract address, right? So that's the idea.
Aha, it's like how in Solidity you have prank user. This is the equivalent.
Okay. I didn't get that.
See on Foundry, the Solidity version, you wanted to
Okay.
create a random address, you'd use prank user. So this is the equivalent of using like prank user now on Stacknet.
No, what prank does is different. when you
So
say prank is basically saying you are executing that call in the context of that person, right? We are still going to see that, right? But yeah, I'm creating an address, right? That's what I'm doing. I'm creating an address, and I don't want to specify, like say user, which is a field, which is supposed to be a contract address. So I can still like do this too, contract address, and say user, and then I can, I should be constant rather. I can typecast this into try into dots on wrap. So I have to bring in use traits try into to get it to work. Okay. Should yeah, that's but basically, I can do this. I don't know why the compiler is not picking it up. I think maybe there's an error. But I can do this, right? But I choose to like go for this approach instead. So instead of like creating random instead of sorry, random is not the word to use. Instead of like just creating any address, say I say 0x something, right? So this is like a more modularized way for me to a much more cleaner approach to like create an address, right? And you're also going to like see the use case. So for start prank or any cheat code like that, there are like functionalities for you to like simulate, impersonate, or do um give you like extra functionalities, Shad. An example of that you mentioned start prank is to like simulate a call in the context of that person, of that address you're specifying. Do you get? So it's doing something different. What this is doing is just like creating a user address, basically. That's the idea. uh failed to 5 2. Okay, so we've done the setup, and we are going to like can add more content in here. So now we want to like say test our constructor parameter. Test constructor. Let's use as test constructor. Sorry, minutes, please. Yeah, so test constructor. Now we already know that we have to like get what do we call it? Our contract address, right? Which is returned by the deploy contract. And we know that we need a way to like be able to like make calls, which means we have to like specify our interface. And since we are inside our contract, you can easily like reference it using super IRC dispatcher. So this brings like your dispatcher into the context of this test. So to get let's yes.
Sorry, where is the IRC20 dispatcher declared in your contract?
Yeah, I have when you define in Starknet contract, when you define an interface, right, it automatically generates a dispatcher for you, a dispatcher, a safe dispatcher, a library dispatcher, and so this dispatcher enables you to like make external calls, right? So we are leveraging on that capability to be able to like make calls in our test. So I don't necessarily like so since it is auto-generated, that means I can import it in my test. And if you check this section for I think Starknet, say Cairo book, yeah, Cairo book not found. How come? Sorry, give me a minute. I'm coming. Cairo. Let me just do Starknet book there. Yeah, section. Not architecture. Architecture is called something. Sorry for diverting a little bit. I just want to like give us pointers on something. Cairo book is CS existing today. Why is it not? Yes, it's straightforward in Cairo book. Ah, interesting. Sorry, let me quickly raise an issue. Uh, okay, I'll do that later. Yeah. So the idea of dispatcher is sorry, give me a minute. Um, can you still see my screen?
No,
You can't see my screen. Oh, I'm coming, please. Sorry, a minute. What about now? Can you see my screen now?
Yeah. Um, yeah.
not yet now.
All right. So I think I would share once the page is back up. I would like I find like I'll compile a list of resources and like write the content which they contain. But basically, when you specify interfaces in Starknet contract, it automatically generates a dispatcher for you, and this dispatcher gives you a way to like make external calls, right? And that is what we're leveraging on here. So that's where the idea of dispatchers comes in. So you have dispatcher, you have safe dispatcher, you have library dispatcher. Each dispatcher have its own functionality, right? But they basically like work the same, but then their use cases are different. So we want to test the constructor parameters, right? So this dispatcher variable now gives us access to all our functions in our contract. Now, so how create result token name, which is dispatcher dot let result token.
Sorry, the link is
Yes,
being sent
I
to the
didn't. What did
chat.
you say?
The link is
Eh?
being sent to the chat. Like a link is being sent to the chat.
Okay. All right. Thanks. I think yeah, maybe they've changed the. Let me just. Okay. Yeah. I think they already like changed the So a section here, contract dispatchers. So I think um in the first in our first class, I don't know if you recall correctly, we made difference between Starknet contract and Cairo programs, right? Sorry, yeah, Cairo programs. Yes. So Cairo programs are programs written in native like Cairo, right? Cairo, like the normal Cairo, Why Starknet contract are contracts that has access, like there are programs that has access to the Starknet state. So if you want to go through this Cairo book, right, it gives you fundamental introduction to Cairo as a programming language, right? As a provable programming language, right? Like the control flow, ownership, and a lot of content. There's a section, this 12, that talks about Starknet contract. So it's specific for contracts alone, right? The remaining modules are like introduction about Cairo. So when you come into this like this section 12, you can read everything about contract, and we'll go down to APIs and cross contract interaction. This is where interface is like being discussed in details, right? Have your API and then talks about interfaces. And this contract dispatcher we are using now, you can come and read about it later. So it gives you a overview of what contract dispatcher is, gives you overview of what library dispatcher is, and gives you overview of like how you can like utilize them and things like that. So you might want to like check it out. So I have dispatcher dot symbol, and let's resolve token decimal. So dispatcher dot decimals. Yes. Now we want to like make assertions. Assert. So we're making like three assertions here. So we want to like bump up our error. Invalid decimal. So first is result token symbol. Assert that result token symbol is equals to token name. If it's not correct, then execute this error invalid name, then assert that result token. Sorry, some should be name. Symbol is equals to token symbol. If not, error invalid symbol. In decimal. Okay. Let's say intent about into in decimal. Token decimal is okay. Yeah. So please, are we still following?
Yes, please.
Yes, please. All right. think I should bring this one out of yeah. Okay, it's out. I should run tests. Let's see if it's going to pass. Okay. Entry not found. Entry not found. Okay. Yeah, so I think I know what the issue is. Remember that we are like trying to like test individual functions. I think I didn't specify external view for this. Yeah. So what the issue was, I already specified constructor parameters here, and I am implementing my ERC20. Like I am making like I'm implementing the interface here, right? And I had to like specify the um, attribute external to it. Basically, this is what the this makes like the functions visible where I'm able to like make calls, right? I think we understand like the what the concept of external, public, and the likes in Solidity, right? So similar to that, when you specify external on your implementation, so it makes your functions like visible. So I think this should like erase the error, and it should pass successfully now. Oh, my goodness, how my system is close. Can we still like see my screen? Sorry, my VS Code just like froze now. I'm going to like set it up again. Alright. I'm not doing anything to why now. Okay. Because are you still with me?
Yeah.
Sorry about the interruption. My PC just decided to be unfortunate. Yeah, so let's send fudge test. Yeah, so the test passes, right? So we're able to like assert for the token name and symbols. Just a little bit of recap on what we've done so far. We know that when you want to deploy your contract either to testnet or mainnet, you have to declare. You have to declare the contract to get the class hash, and also um, after declaration, you can then deploy. Yeah. So what I did here is the upper function is help us to like deploy our contracts, right? And then we know that it contains constructor parameters. So, we declare the contract on line 206 and specify the core data, I mean the constructor parameter we're expecting. If we are not expecting any constructor parameter, it will be an empty array that will be passed in here, just as we saw previously. And we unwrap the data, the result of this to get our contract address, and then we want to test the constructor parameters, right? We are testing the function name, symbol, and the token decimal here. So let's write a test to like test the total supply function. Test water supply. So just as you know, you have to like get your contract address, and then you have deploy contracts, and yeah, basically same approach. Dispatcher is equals to hierarchy 20 dispatcher, specify your contract address. And what function do you want to call? Let's say result total supply is equals to dispatcher. Please don't freeze again. What's causing all this? That's supply. Now we want to assert that result total supply equals to 0 because we are yet to like meet any token. So invalid. So you can specify your errors, but I prefer to like specify it here. So before, like I um, do specify the error in like in the assert, but then while like taking a look at OpenZeppelin's code base, right? Like when you write code, you always have to like look at other people's code and see what the standards are. So that was where I got to like see this implementation of errors. So if you have like a very large code base, you know this approach is very like modular and straightforward. So you can just have like say error.cairo, and then you specify this module, and then you bring it in. Say I want to like create this now. Say I say error.cairo. I bring it in here. So let me just use session testing them. Let's go. Let's go. Okay, I have to like specify. No, don't. So let's just revert back. I have to like create a separate folder and stuff. Should work out of the box, but yeah. But yeah, that's the idea. So it makes your code like very like clean and stuff. So let's run this.
How did you import it, that error.cairo, onto your new process?
If I wanted to like do it right, I have to like create a folder for error and specify the module inside basically. But I didn't import it anymore. I just like decided to go with this formal approach.
Don't give up. I
But then
think it's worth doing it.
to get the idea about how file modules work in Cairo, you can check this section. Yeah, managing Cairo project with packages, crates, and modules. So this section talks about you how you're like how importing of files works in Cairo and how you like import modules and sorry, and how it should how like import works basically how modules, part and packages and crates basically works. So let's send forge test. So it passes. Now, so I want to like mint, and the function to mint is here, but then this is where like the stop prank list, the prank sort of like comes in. Sorry, I have so many. Yeah. So I have to bring start prank, stop prank. Yeah, so what I want to do is in this in this deployment stuff. So instead of like minting for, because every if I want to like test minting here now, whatever execution I do here would be specific to this test. But I want to like make a global minting to a particular address. So why I want to deploy, I want to like prank this user. So what I want to do here is your start prank basically like runs a particular execution in context of that address you specify and returns to parameters. So let's just see it in the documentation itself. So yeah. So let's talk about cheat codes. So Starknet Foundry gives you a lot of cheat codes you can work with, and what you use cheat codes for basically is um, right, like there are lots of like use cases. Say the start prank, like we want to do now, changes the caller address of a contract, right? Stop prank, cancel the start prank for the contract. Start rule changes the block number of a contract. So your contract will determine like your use cases of these cheat codes. An example is, say you have like a staking contract that is dependent on block number, right? And you want to like calculate the reward is going to like give you at a particular block. So this start rule is very useful. You can like utilize it to like roll by the number of blocks you want, and you get your result. So you can see the implementation and the example here. So you specify the contract and then you roll by this number of blocks. So you have start WAP, say you still have still your staking contract, some functions depending on timing. You want to calculate the reward, the time it takes your user to like get the reward, right? You can easily like warp time. Warp time basically means you're traveling in time, right? You're warping to the exact time you want to um, um, you want that execution to occur, you want your reward or something like that, right? Changes the block time for a contract, right? So it gives you the this sort of like power to be able to like um to like it gives you this sort of a power to be able to like make your testing like easy or something. I don't know, the English is not coming, but then you get the idea. But these are just cheat codes basically, so you can like look into them and see what each cheat code does. So we want to like take a look at what do we call it, start prank now, and we know that uh, yeah, start prank, right? Let's see. It takes into parameters the contract address and then the caller, right? The person you want to like simulate the call in his own context. So the contract address, we remember that we have already deployed our contract here and returns an address to us, so we can easily pass it. So the account I specified here now, I'm going to import it. So use super account account. I want to really use one. So I'll just execute user one. Right. So what do I want to do here? I want to call mint dispatcher. Oh, no. So in here I have to like get my dispatcher to be equals to hi dispatcher. Remember your contract address. So I hope we are following. Hope we are not like confused in any way. Then you specify the contract address. So let me just create a constant that says const. Okay, mint amount should be 256 1000. So any questions so far?
Yeah, could you please share the link of the site you're on right now? That's what Timothy asked.
Okay, Starknet Foundry. Yeah. Starknet Foundry. So sorry, I will update the slide before sharing it tonight, so it can contain these links. Yeah. So what I'm doing here is I'm pranking this person. I'm executing this call in the context of this user one, and I'm minting this amount to the person, right? So let's so this total supply is going to fail. So since we know that it's going to fail, um, pa- 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 pa. let's try something. Let's try. Okay. Let's just change this to mint amount and test the balance of user one. Function test user one balance. Oh, yes. It's not supposed to return anything. Okay, same let's contracts. Let's just deploy contracts. Let's just purchase equals to why is this thing slow? Okay, Zoom consumes a lot of stuff. Self. Yeah, so what I want to execute here is let user balance. So balance equals to dispatcher dot balance of what who am I trying to get user one, right? So I have to assert that user balance equals to what now, mint amount, if not invalid. Say let's call it invalid amount. Yeah, so I think we have 4 test cases now. So test is sorry. Yeah, so our test passes. So when we are writing test, you might see find instances where your test might fail. Say you want to print. For people that are familiar with Hadat, how do you like print? You have like console.log exposed to you by JavaScript, right? So you have something that helps you to like debug. So you have you just specify use debug, and then you have a print trait. So this print trait gives you functionality to be able to like print out anything. So say we have user, I want to print out what this user balance is. I can easily say dot print. So when I execute this function, it should print out. So this print is like your console.log that you're familiar with in JavaScript. So we have little time. So let's test transfer. So
Why did you specify the mint amount?
mint amount is a constant here. So you can see that it gives you like the output of this, right? And if you should convert this egg and this hex to decimal, it's going to give us the
So
required amount.
like that mint amount, I can't see where you have declared it in the contract.
Yeah, mint amount is here. I'm coming online 199. Can you see?
Ah, yes.
Yeah. So yeah, so I want a second user. I can easily like add, create, use this and specify user two. So here I have user two. Yeah. So let's test user two's balance. User two's balance should be 0. User two should be 0. Right. So let's transfer between user one and user two now. That will be test function test. Oh, nice pancakes. So we're going to like use our start prank here. Prank user one and specify contract address. So we want to execute dispatcher dot dispatcher dot transfer. See, let's specify transfer amount. Say 100. Ah, come on, this is something else. Okay. So if we check our transfer function, what is it expecting? Transfer is expecting recipient and amount, and the recipient should be user two, and then the amount should be transfer amount. So we're going to like stop prank here, contract address. So in this, because we want to assert that user one balance, say dispatcher dot balance of user one minus user two. Please, are we following? Is there any questions as well? Okay. So yeah. All right. So I thought that user one balance equals to 900. Yes. Yeah, valid balance and assert that user two balance equals to 100. Yes. So while we like wait for the thing should be done testing. Okay, invalid balance, testing transfer. Okay, this is failing. Okay, user one due to special the balance with user one start from contract for user one. Okay, so one balance that's print. Okay. Valid balance converted to string 0x. Sorry. Uh, uh, Sorry, I'm trying to like debug something here. Okay, 1000. Okay, we didn't transfer the amount. Prong. Okay. Seems the transfer didn't work. So start rank user. Right. Uh, okay. Transfer. Okay, let's try. Yes. So aside this like start prank, I already mentioned that Starknet Foundry gives you a lot of functionality to like a lot of cheat codes. So you can also like similar to Foundry, it gives you functionality to like fork mainnet. What I mean by fork mainnet is like create an instance of the main network, right? So you can create an instance of the main network, you can create instance of the test network, or you can also like deploy locally by spinning up a local blockchain yourself, right? So you can like check out the docs to like see how these things work. So fork testing is here, right? So I think I can share like a code base that has like implementation of forking if we don't mind, because our time is fast spent now. I quickly want to like show us about first testing. Let me see. Oh yeah, okay. Passes now. So I think it was the order in which I arranged things earlier that made it fail. So we can see that the yes.
You can send the link to this one that Foundry RS.
Yes, what I'm going to do is that I'm going to like compile all the resources I have in mind, right? Because I didn't actually like see the need to like had any resource earlier, but as we are going through the class, just resources just keep coming to my mind. So I'm going to like attach them to the slide and have the slides shared later this night. I'll do that immediately after the class. Yeah, so we can see that our test is passing. So I think we have like, yeah, so this is like writing unit test. Now let's see integration test. Integration test is basically it's the same. So you have to like specify your contract has to like the name of your contract has to folder has to like file rather has to start with test, say test ERC20 dot Cairo. So there isn't much to do here. All we have to do here is just like copy all we have written here, right? Take it away from here and paste it inside here. But then there are some differences. Initially we specify this mod test ERC. It won't be there anymore, right? And also what we need to do now is to update our, what do we call it? Our imports, right? So use session test demo. I have to bring in the ERC20. Use session test demo by ERC20. Um, okay, sorry. Let me just update it here. Uh, comments. Accounts which are not found. Cases. Let me just take this one in here back and specify it here. Sorry. Oh shit. Yeah. So if I should run this test, hopefully it doesn't fail. And if it fails, we're going to like look out for a solution. Yeah, so basically it works. So the basic idea is when you're writing unit tests, you have to like right, like you saw the implementation, right? So unit test is you testing the individual functions. Say you don't really like have I don't really like know, like it's based on personal preference. You might decide to like write your test in same module in which your contract is, but to like keep things modularized, like have separate separation of concern, right? So it's advisable to have your test written separately. So you see that nothing really like changed per se. What changed is just like the imports in which we we have, right? So the other approach to testing contract, which I wanted to like talk about, is like using contract states, right? And this is how it. So let me just demonstrate that with a simple unit test here. CCF CFG test. Then you have mod test. So You have a function state that returns to you the yeah, see, so I have to bring in the I have to import the use super, yeah, see 20. So I have to bring in here I see 20 contract state, which is basically going to return to me here as a 20 contract is for testing. Yeah. Let's state. Yeah. So this approach is like quite different. You're not like declaring, you're not deploying, but rather you're having access to the contract state directly using this approach. So let's just quickly like test what do we call it? Say we want to test constructor params. Right, so I have to like get my states from here. State. So this state now gives me like the functionality of everything. So I'm able to like call the functions available here. And the interesting part about this state is it gives you functionality. It gives you like the ability to make to call what do you call it now? To call internal functions. The approach we did here only gives you visibility to contracts, to external contracts, right? But then what if you want to like make call to your external contracts? Of course you have to go about this approach. Like say you want to like make internal, you want to like call internal contracts, internal functions, right? So you just like create this simple setup, and you are able to like call your like your internal contract, which is this underscore approve underscore um, allowance or whichever way. So for the constructor parameter, what I want to do is what I want to do. Yes, I want to constructor expecting expecting 4 parameters. Yeah, so I think let me just copy from here. Um, token, just copy. Yeah, sorry, please give me a minute. Yeah, so bring it back here and yeah, aside this test. Yeah, so to specify the constructor parameters. So now when you're using this approach, you understand, you remember that when you want to like mutate state, you have to like specify the contract state, right? When you want to read state, you have to specify the snapshot. So here, same similar approach. I think you would have to. So let's just pass in the parameters first. Token name, token symbol, and token decimal. Yeah, so it's saying expected 4 parameters, but getting 3. So you have to specify your state here. I think you should be ref. Yeah, okay, must be mutable. Yeah. So um so the I don't know if we get the idea here, but what we are doing basically is let's go back to our constructor parameter. In our constructor, you're specifying this contract state, right? You're saying you want to mutate this state, right? And you are passing additional parameters. Similar approach when you are using the contract state instead of dispatcher, right? You have to pass in that same state, the contract state basically, because the setup we did here returns the contract state to us, right? And in your constructor parameter, you're saying you're passing the contract state, right? I don't know if this is making sense to us. Are we confused? Oh, 10 minutes. Yeah, okay, let me just quickly finish up the code then. So where I saw this implementation is OpenSea Berlin's contract. So you might want to like give it a try. So if I want to assert now, all I need to do is say assert state dot name equals to token name invalid name. Company. I don't know why this IntelliSense chooses to. Yeah, so let's. This should work. Shouldn't. Where's my PC slide now? Please not again. God. It's like there are people against our class. They are using us. Please stop.
Are you still there?
Sorry,
Yeah,
can we hear me?
yeah, I can hear
Sorry,
you now.
my PC just froze. I don't know. Sorry, I will like update the code and share with us. Can you guys hear me?
Yeah, I can hear you.
Yeah, so I'll update the code and share with us. And I believe like we learned a number of stuffs today. And if there is any area that is not clear, please reach out to me so that I can like we can like clarify. And if it's beyond my understanding, you can always like reach out to them to other developers in the community channel or Starknet Foundry channel itself. So I would work on the additional resource I said I was going to like add to the slide and share, and it will be shared before 10 tonight, hopefully. So sorry about the break in transmission. Does anybody have any question about this session? All right. Thanks for joining the demo.
Yeah, thanks for the section, man. It was very good. And yeah, so we'll be looking forward to the slide. You can just share it in the Telegram group when you're done adding the links you say you would add. And
okay.
And for everyone that has been actively attending this bootcamp, it's actually a pleasure to have you all. And so at the end of this bootcamp, just like I said in the last section, we are going to have every graduate, we're going to have a section with the Starknet Foundation with every graduate that came out of this class. And also we're also planning a little hackathon that people can build for a few days. And also there will be prizes as well. But we are just focusing on making sure that the graduates of these classes, this bootcamp, have enough visibility, enough knowledge on what they are like learning. And yeah, so we look forward to having you guys on the next section, which is next week, Thursday, same time. And do have a lovely night.
Yeah, bye everybody.
Yeah, bye.
Then one suggestion. These recordings, each day's recordings, will also been sent to an email because I haven't seen them on YouTube yet for this particular cohort.
Oh, it's actually on YouTube. Do you just search Starknet Africa on YouTube? You will see.
Oh, Starknet Africa. Oh, okay.
Yeah,
Sure.
I think I have to like start doing that. I would send out the email would contain the link to the recording. Sorry about that. Okay, yeah. Good night, guys. Yeah.
Have a nice one. And the
Yeah.
slides too.